Hello, in this video I'm going to be going over angles, how we can measure angles, and then how we can convert between different units of measure for angles. So the first thing to talk about is a ray, and a ray is simply a point that extends in one direction. We can label this as A, B, like this, and how we name that ray would be ray AB like this, or we could also say AB with a little ray symbol above it. Now an angle is made up of two rays that are connected at a single point, and we call that point a vertex. Okay, so that's two rays joined at this point. Let's call it A. I could also, so that's this first definition. I'm sorry, that's the second definition. The first definition here, so I'll put a 2 here. This first definition for an angle is when we have a ray like this. Say we have point A and maybe B, and then this rotates so that we have kind of the ending position of that ray like that. So that's another way that we can create an angle. Now, this angle here, let's say that this is B and this is C. If I wanted to name that angle, I could call that angle A, or we can use this angle symbol, and we always use the vertex. If we're just going to use one point on the angle, we use the vertex. So in this case, it's A. Another way we could do this is we could name all 3 points on that angle. So we could name this angle CAB or angle BAC. Now in each case, we make sure that the vertex is the middle letter in that 3-letter sequence. Lastly, we can use the angle symbol. So I could say angle CAB or angle BAC, and again we want the vertex to be the middle letter there. We also often will use Greek letters for our angles. So here's some Greek letters: theta, alpha, beta. So theta, alpha, and beta. Okay, so I could put that angle theta if I was kind of running out of space here, but let's say I have this angle. I put the Greek letter inside the angle like that. So angle theta is there. Moving on, we want to talk about some different types of angles. So we have acute angles, obtuse. We have right angles, straight angles, vertical, and quadrantal angles. So we'll talk about what each of these are. So an acute angle is it measures less than 90 degrees. An obtuse angle is between 90 and 180 degrees. So if I was to draw an acute angle, it might look something like this, so less than 90. An obtuse angle might look something like this. A right angle is an angle that measures exactly 90 degrees. And that is going to look like this. And we put that little kind of square box at the vertex on the inside of the angle to indicate that it's 90 degrees. A straight angle is exactly 180 degrees. So a straight angle would look like this. Vertical angles, those measure when we have two intersecting lines, and these angles here and here are vertical. So vertical angles are angles that are kind of across a vertex from each other. These green ones, are also vertical. And vertical angles are always equal to each other. So this angle and this angle Those are vertical, and those are equal to each other. And then I misspelled quadrantal. I forgot the L. And that's an angle that lands on 0 degrees, 90 degrees, 180, 270, or 360. And we'll talk more about those here in a moment. Quadrantal angle is not the most important type of angle, or just we don't use that terminology very often, so I wouldn't worry too much about that. So let's talk about how we measure angles. There's two types of units. We'll use degrees and something called radians. If we are measuring an angle in degrees, it's usually between 0 degrees and 360. Although we could have a negative degree measurement, and we could also have an angle measurement greater than 360, and we'll talk about when that happens. But typically we are between 0 and 360 degrees. Radians, if we're measuring something in radians, it's between 0 and 2 pi. And again, we could have a negative radian value. We could also have a radian value greater than 2 pi. And again, we'll see how that looks. All right, so some more terminology. We have a central angle, and that's an angle whose vertex is at the center of a circle, or it's in standard position. So if I have a circle here, there's the center. Here's a central angle. It's just an angle that's at the center of the circle. If I want to draw an angle in standard position, that's when it's on the XY plane. And in that case, my first part of the angle is always on the x-axis, and then we call this the terminal side. So here is my angle right here. So what we'd say is this right here on the x-axis is the initial side of the angle, and then this is the terminal side. It's just when we're rotating the angle, it's where the angle stops, so the terminal side. Now, if we are rotating an angle clockwise or counterclockwise, that's going to indicate or determine whether the sign is positive or negative. So this angle that I drew up here, that is getting rotated counterclockwise. So that has a positive value. Sometimes I can spell. Let's try that again. Positive value. And then if it's clockwise, that will have a negative value. And this applies whether we're measuring the angle in radians or degrees. All right, so what is a radian? Now, most of us are more familiar with degree measurement. And degrees, we come across degrees much more often. 1 time around a circle is equal to 360 degrees. If somebody, in the X Games does a trick, maybe on a snowboard where they rotate 2 times, we say that's 720 degrees. That's 2 times 360 degrees, and so on. So we're pretty familiar with degrees. Radians, we are not as familiar. So let's talk a little bit more about that. So 1 radian is the measure of a central angle. So this angle that I have right here is a central angle because it's centered at the center, or the vertex is at the center of the circle. So that angle measures 1 radian if the radius, so here's the radius of this circle, right, from the center to the edge, if the radius is equal to whatever this arc length is, right? So all of these blue, they're not all line segments, but all of those blue portions are equal. And when that happens, this central angle, I'm going to label that as theta, has a measure of 1 radian. So here, theta is equal to 1 radian, and that is, again, because the radius is equal to the arc length. Now, if I draw a circle, another circle with a central angle, now instead of 1 radian, now it's going to have 2 radians. And the reason here is because if this is the radius of that circle, this length right here is equal to r, this length here is also equal to r. So this central angle, now I'm going to call it alpha just to give it another letter. Now this angle is equal to 2 radians because it's as though I'm laying down the radius 2 separate times on that arc length. Okay? So in a circle, in any circle, no matter what the radius is, let's call that r, I can always fit a little bit more than 6 radii around. Now, this isn't perfect, but I have 1, 2, 3, 4, 5, 6 radii, and then a little bit extra right here. Okay? So what we say is it's 6.28 radians in one circle. And that's not an exact, so I'll say 6.28 ... radians in one circle, and that is equal to 2 times pi. Remember, pi is roughly 3.1415 ... So I can fit 2 pi radians, or 2 pi radiuses around any circle. So that's where that measurement for the entire way around a circle for that angle, where that comes from. Okay, so to convert between radians and degrees, what we need to remember is that there is a conversion factor. So 2 pi radians is equal to 360 degrees. Okay, so usually I can simplify that fraction to pi over 180. Or I'm going to use this conversion, 180 degrees over pi. So to do this conversion, all we're going to do is multiply the given angle by one of those conversion factors, and then we'll be able to make our conversion from one unit to the other. So in this example, convert each of the following angles to degrees. So all of these are in radians. Anytime we have something with pi, that implies that the measurement is in radians. We say that radians is a unitless measure. In other words, we don't write radians unless we need to, like this one, where it's not clear. But when we see pi, that indicates that the measurement is in radians. Okay, so our first angle here is pi over 3. What I'm going to do is I'm going to multiply by one of these conversion factors, and the conversion factor I'm going to use is the one that has the unit in the numerator of what I want. I want to convert this to degrees, so I'm going to use this conversion factor because degrees is in the numerator, degrees is what I want. So I just multiply these fractions. We'll do this slow and steady here, so 180 pi over 3 pi, and then I can simplify that. The pi can factor out. 180 divided by 3 is 60, and I want that in degrees. So 60 degrees is what that converts to. 3 pi over 4, I'm going to do the same thing, times 180 degrees over pi. I'm going to go a little bit quicker this time. I can cross-cancel the pi's, and then 180 and 4 can both be divided by 4, so I end up with a 1 down here and a 45 degrees here. So what I'm left with is 3 over 1 times 45 degrees over 1. So 3 times 45 is 135 degrees, and that's what we end up with. And then 1 radian, if I want to convert that, well, 1 radian times, I'm in radians, but I want to convert to degrees. Okay, nothing cross cancels here, so I just have 1 times 180. I get 180 divided by pi. And if you type that in your calculator, 180 divided by pi, if you press the pi button, which is, again, 3.1415, etc., we end up with about 57.2958 degrees. All right, so that's how we convert from angles to degrees. And then let's go the other direction here. So to convert from angles into radians. From degrees into radians. So 30 degrees, I'm going to convert that into radians. Now I'm going to put the radian measure in the numerator. So I'm just going to use this other conversion factor. I'm going to use this one here. So I can cross cancel 30 degrees and 180 degrees. I can divide them both by 10. I could get 3 and then 18. Or I can actually divide these both by 30. So this gives me 180 divided by 30 is 6. So I just end up with pi over 6 here. 90 degrees, if I convert that into radians, 90 and 180, I can divide those both by 90. I get 1 over 2. So this is just pi over 2. This next one, negative 225 degrees times pi over 180. We mentioned earlier that if an angle is negative, that means it's getting rotated in the negative direction. So this angle, I have this, and then 225, but in the clockwise direction, I'm going to end up here. So there it is, my angle. I can multiply this out. I'm not sure what the biggest common factor between 225 and 180 is, but I know that I can divide both of those by 5. And if I do that, I get 45 degrees, and 180 divided by 5 is 36. So I get 45 pi over 36. And I can still reduce this. 45 over 36, I can divide those both by 9. So this is 5 over 4. So what I end up with is I end up with 5 pi over 4. All right. And then similarly for this last one, 55 degrees times pi over 180. Again, I'm going to divide both of these by 5. I get 11 over 36. Ultimately 11 pi over 36, and I can't reduce that any further. So that's it.